Hello. So today we're talking about solving linear inequalities. And like a linear equation, linear inequality means that if your variables, however many variables you have, they're all the first power. Today we're going to focus on solving linear inequalities in one variable. So our goals will be first to make sure that we understand differences between equations and inequalities, and then also be able to solve linear inequalities in one variable. So first, let's talk about what the differences are. So there are two main things. So we basically have the same rules for solving inequalities do for an equation. You can add the same thing or subtract the same thing for both sides. And also multiply or divide both sides by the same non-zero number. But the only difference is when you multiply or divide both sides by a negative number, you reverse the inequality sign. That's the only difference. It only happens when you multiply or divide both sides by a negative number, but only then. That's the only time. The other difference is that your solution are intervals of numbers, not just individual numbers. So for an linear equation in one variable, our solution is just one number. But when you have a linear inequality in one variable, your solution is an interval or kind of a range of numbers. And we'll talk about how to write those. So it says when writing solutions interval notation, use brackets or closed circles are used when the endpoint is included. And then parentheses or open circles when the endpoint is not included. Okay. Parentheses are always used with infinity or negative infinity. We'll discuss these. And also, solutions can be written in what's called set builder notation, which we're not really going to look at right now. So let's first off look at some examples. First, let's understand the difference between, I said, an equation and inequality. Okay, so first, let's look at the equation. Just do a simple one, just x equals 1. Okay, that's just a single number. And if we graph that on a number line, or here's 0, then here's 1. We just put that as a closed dot. That's it. That's our solution. That's the only value. Okay, now what if we had something like x is less than 1? And this would also be the same idea for any of our four inequality signs. X is less than 1. What that means is that if we graph that on a interval, and here's 0, here's 1. Okay, a couple things to note here. Now, 1 itself is not included. Okay, that's why you can use an open circle. That means that 1 is not included. If you try to plug in 1, you'd have 1 is less than 1, which would be a false statement. Now, it also says that x is less than 1. Okay, so basically that means everything to the left of 1 is a solution, just not 1. You can also get as close to 1 as possible as you want without actually being 1. So 0.999999 forever would be correct, just as long as it's not actually 1. And also nothing to the left of, to the right of 1 is a solution. So if you plug in 1 here, you get a false statement. Also, you plug in, say, 2 is less than 1, that also be false. Okay, so with a linear equation in one variable, you get one solution, an individual number. With a linear inequality in one variable, you get an interval of numbers. Okay, and that endpoint may or may not be included, depends on the sign. If this been x is less than or equal to 1, we would fill that in, meaning that 1 would be a solution. Okay, 1 is less than or equal to 1 would be a true statement. Okay, now let's look at some examples of equations. Let's solve those. So what we're going to do then, oh, actually, one more thing I want to include on this. Our solution, we can also write this in interval notation like this. So we'd have, we get this from our graph. So 1, our right endpoint is 1. You have everything to this side, so that's going to be, goes from here back to negative infinity. So that's our left endpoint. Of course, infinity or negative infinity are not numbers. They're just kind of ideas that keep going forever. Okay. Now here, since this was less than, 1 wasn't included, we indicate that by using parentheses. And then as it says, when infinity or negative infinity, we always use parentheses because they're not actually numbers. They can never be included since they're not numbers. Okay, so we can also write that in interval notation like that. Now, let's look at solving some examples. So our directions, I'll say to solve. Also, we'll say we want to graph the solution. And then also we're going to write in interval notation. So like we did here. Okay, let's look at our first one, number 1. Let's do a basic one. So let's say we have 5x plus 2 is greater than 1. Now, our goal is just like it is with an equation, we want to get x by itself. And we said our rules are mostly the same. So to get x by itself, first let's subtract 2 from both sides. Now also remember, our only change is that if we divide or multiply both sides by a negative, we reverse our inequality sign. So what that also means, with adding, subtracting both sides to inequality, or I may have said equation, sorry, inequality, then we never change the sign. So our sign is still the same after this. And so we have 5x is greater than -1. Then, of course, divide to get x by itself, divide both sides by 5. Here we're dividing both sides by a positive, so we don't change our sign. And we have our solution then is x is greater than -1, or -1/5. X is greater than -1/5. Okay, now, so first let's graph that. And then from that, we'll be able to write out our interval. Okay, so here's 0. Okay, so -1/5, of course, is this side. Here's -1/5. In this case, once again, it's not the or equal to, it's just greater than. So we use an open circle to indicate that the endpoint is not included since it doesn't have the or equal to part. This is greater than that, so everything to the right of -1/5. So graphically, that's what our solution looks like. And then in interval notation, as an interval, it's going to look like this. So we write our endpoint. So our left endpoint is -1/5, and our right endpoint goes all the way from there to infinity. So it's infinity. And once again, here, since endpoint is not included, we use parentheses, indicate it's not included, and infinity or negative infinity are never included, so always use parentheses with them. So there are 3 different ways then we can write the solution, okay? As an equality statement, on a graph, or as an interval. Okay, next one, number 2. Okay, let's have this one. So -4x is less than or equal to 8. All right, same thing. We want to get x by itself. Here, there's not as much to do. To get x by itself, we need to divide both sides by -4. But since we're dividing both sides by -4, over here, this is x. This is going to be -2. Since we divided by a negative, everything is multiplying both sides by -1/4. We need to reverse our sign. This is greater than or equal to. This becomes, sorry, this is less than or equal to. It becomes greater than or equal to. Okay, then that's it, because x is by itself. Now, once again, if we graph this on a number line, here's 0, here's -2. Similar to the one we just did, except this time we have x is greater than or equal to -2. Since we have the or equal to part, we put a closed circle because the endpoint is included. So if we plugged in -2, it would be -2 is greater than or equal to -2. That's true because of the or equal to part. And here, it's greater than, so it's everything to the right of -2. Okay, so that's our solution. And then as an interval, our endpoints are -2 to infinity, like the last one. Infinity is not included in this case because we have the or equal to part. The -2 is included, so we use a bracket for that. Okay, and that's the solution of that one. Okay, number 3. x minus 2 is greater than or equal to 2 times x minus 5. Okay, this is similar to something you may have seen as an equation. Okay, so before we can think about getting x by itself, we need to simplify both sides first. Okay, now if you looked at the left side's already simplified. I can't combine these over here, but here on the right side, I can distribute the 2. Okay, and once again, since I'm just doing this on one side, that doesn't affect the sign or what the other side at all. So I have x minus 2 is greater than or equal to, and distribute the 2, we have 2x, and then 2 times negative 5 is negative 10. Okay. Now, here, let's say I want to get, let's say I want to get the x by itself. And since I want to get the x by itself, once again, this is a choice. I'm going to choose to get the x on the right side. Once again, that's just a choice. It's a good idea to, after we do this one, at some point, try this on your own, get it on the other side and make sure you get the same result. Okay, so you've seen this before. I want the x's over here, so I need to move the 10 over there. The way to do that is add 10 to both sides. Okay, so that crosses out. And so we can also kind of do this in one step if you like. So then I can subtract the x on both sides to get the x over here. What I'm left with over here is 10 plus 10 negative 2 is going to be positive 8. Remember, adding, subtracting never changes our sign. Then over here, I have 2x minus x is just going to be x. Okay. Now, this is kind of an awkward way of saying it. It's still true. This says that 8 is greater than or equal to x. I can rewrite that just by reversing it, or let me say rewrite it by reversing. And what I mean is just switch our endpoints, switch our numbers here. So here we have x, here we have 8, then reverse the direction of our sign. Make sure this says the same thing to you. 8 is greater than or equal to x is the same as x being less than or equal to 8. Make that look better. Okay. Now you always do that. Could do that up here as well. Okay. I could have had up here at x is less than or equal to negative 2. I could also written that as negative 2 is less than or equal to x, but this is better. It reads more easily like this. Once again, either one is correct. Okay. So once again, if we draw our number line, so here's 0, here's 8, and then once again, we have the or equal to part. So 8 is included, and it's less than 8. So everything to the left of 8 all the way back to negative infinity. So as an interval, our endpoints, it goes from negative infinity on this side up to 8. Okay, and negative infinity is never included. It's always parentheses. And then 8, since they have the or equal to part, we have a darkened circle. So use a bracket there. Okay. So that's basically how you solve basic linear inequalities in one variable. Now let's look at one more type of inequality you may encounter. And sometimes called 3-part inequalities. And what we mean by a 3-part inequality is we'll explain here in just a moment. So let's come back over to the left. Look at this. So 3-part inequality, I'll just read this. As it sounds like, is made of 3 parts separated by inequality symbols, such as, there's an example like this. Okay. And so to solve, same concept, get the variable by itself in the middle. And all our rules work the same way. So whatever you do to one part, do to all parts. And if you multiply or divide any part by a negative, you just reverse your signs. Okay, so let's do 1 or 2 of these. So Let's do number 1. And I'll just do this one we have. So we have 4 is less than 3x plus 1 is less than or equal to 7. Okay. What I want to do then is get the x by itself, like usual, in the middle. Okay. So if I want to do that, get x by itself in the middle, just like a regular inequality or equation. So I need to get rid of the 1. So subtract 1 this time from all 3 parts. Of course, it cancels out here. And then here, 4 minus 1 is 3. And once again, adding, subtracting, never change your sign. So I'm left with, this is less, still less than. In the middle, I just have 3x left. And over here, I have less than or equal to, then 7 minus 1 is 6. Once again, still getting x by itself in the middle. Divide all parts by 3. And since 3 is positive, I don't change my sign. And so this cancels out. And what I'm left with then is going to be 3 over 3 is 1. Less than x. X is left in the middle. It's less than or equal to 2. Okay, that's my solution as an interval. And once again, I can graph this solution on the number line, and I can also write it in interval notation. Here's 0, here's 1, and here's 2. Okay, and the same rules apply for our endpoints. So 1 is not included since we don't have the or equal to part. So I put an open circle around 1. 2 is included because I do have the or equal to part. So I put a closed circle there. And what this says, x is essentially between 1 and 2, so everything in between these two numbers, but nothing on the outside of it. So as an interval, my solution is just going to be 1 to 2. Then 1 is not included, so parentheses or parenthesis. 2 is included, so a bracket. That's my solution. Let's do one more of those. Number 2, let's say we have -3 is less than or equal to 1 minus x, which is less than 4. Okay, same idea. Get x by itself in the middle. So I need to subtract 1 from both sides. You get this 1 away. So -1 from all 3 parts. And so we have -4. In the middle, we have x. Over here, we have 3. And remember that adding, subtracting never changes our sign. So this is going to be, sorry, this is a negative x in the middle. So we still have the same signs. Now here, and you still want to get x by itself. So to do that, you need to divide both sides, or all parts, not both sides, all parts, by -1. Okay, it leaves me with x here. Here, that's going to be +4. Here, it's going to be it should be -3. Now here, since I divided everything by negative, I do reverse my signs. So this becomes less than or equal to. This becomes greater than equal to. This becomes greater than. Okay. And like the previous example I did before, I can rewrite this in a more normal way, right? I can rewrite it by reversing it. Okay, so what that means, I just switch my endpoints here. So I have -3, 4, x in the middle, and just change the directions of my signs. Still make sure I have the same sign. So this one is going to be less than. This one is less than or equal to. So make sure the correct signs goes with the correct number. Okay, this says the same thing. This basically says that x is between 4 and -3. With 4 included, 3 not included, it says the same thing. X is between -3 and 4, with -3 not included, 4 included. Okay, let's graph this on the number line. And here's -3, here's +4. So -3 is not included, so an open circle. 4 is included, so a closed circle. And our solutions include 4 and also everything in between. And then once again, for our solution, we have -3 to 4. 3 is not included, so a parenthesis, and then 4 is included, so a bracket. So once again, 3 ways to write our solution. And that completes our brief review of solving linear inequalities in one variable. If you have any questions, let me know. Have a good day.